So we're going to continue our parametrics, and we're going to do 1,4b. But we're going to do parametrics of line segments, lines, and rays. So parametrics, we'll just say lines. They're all kind of types of lines in a way. All right, so here we go. We just have like some problems to do. So let's start with doing something like you did in your homework, where you're given a parametric equation to graph. So if x equals 3t and y equals 2 minus 2t, and t is from 0 to 1, and we're going to do a bunch of things. First thing we're going to do is we're going to graph this. You can use your calculator, your graphing calculator, that's fine. Then we're going to, so that's going to be A. B is to find the initial point and the terminal point. That'll be part B. Initial and terminal. And C will be to write a Cartesian equation for this. So in other words, we're going to eliminate the parameter. We want an equation with just x and y, no t in it. All right, so go ahead and get your calculators out if you haven't already. And we're going to graph this. Make sure when you graph this, you change the t. Okay, so you're going to graph x equals 3t. And you're going to graph y equals 2 minus 2t. And then you're going to go to the window and change your window from 0 to 1 and then hit graph. And that looks really gross, doesn't it? No? Try zoom 6 and then change your window to 0 to 1. And then even the t step kind of makes it not look great. But basically what this is, it's just a line segment. So a lot of times a nice way to figure out what the initial point is, if it's too hard to look on your calculator for that, plug in 0. See, this is the initial point right here, and this will be the terminal point. Not the point, it'll be the t that will give you the points of each of those things. So my initial point, I'm going to plug in 0 for x, or for t, and I get 0 for x. And then I'm going to plug in 0 for y, and I get 2 minus 0. So my initial point is 0, 2. That's right here. It's the y-intercept. My terminal point is by plugging in 1. 1 goes in for t, and I get x is 3. 1 goes in for y, or for t to find y, and I get 0. Okay, and my graph just goes like that. It's just a very basic line. It goes in that direction.
We're better off, like, getting the initial and terminal point first and then graphing.
Yeah.
Like, on the calculator.
I know, it looks all
like
weird.
it goes to 3.
It does. It looks like it keeps going, or yeah, and that's because the t step is 0.13. Okay, this is a line segment. It's a line segment because it has a beginning, initial point, and an end point. It's a line segment, and we're going to write the Cartesian equation for this, which is actually not too bad because this is just a line, y equals mx plus b, right? But you do have to say it's a line segment. I'll tell you another way to write that too. All right, so what is the slope of this line? Can you count it off? Down to over 3. So the slope is negative 2/3, and the y-intercept is 2. And if you just write that, y equals negative 2/3 x plus 2, I would think that that would be the equation of an entire line. So you need to either just say line segment, like I did, or you can go ahead and restrict the domain from 0 to 3. X, the domain, is from 0 to 3. So that tells you that you start at 0, you end at 3 on the interval, and your line segments just goes through there.
So we either can put, like, either restrict the domain or write the line segment?
Yeah, and if you don't like that interval notation, you can write it like this. X is from 0 to 3. That's perfectly fine too. Okay? Or line segment. I'm okay with that. It's not really that technical, but. All right, so the next thing you're going to do is we're going to go the other way now. we're going to be given points, endpoints, initial and terminal points, and we have to come up with our own parameterization for it. This is a little tough. It's nice and easy with a general formula, okay? So here we go. This is a formula for a parameterization. It's a big word. It's your big word for the day. Formula for parameterization of either a line segment, or array, okay? And I'll show you each of them. They're different. The formula is the same, but then the t's are different. So here we go. Here's the formula. So if I had to come up with, like, you know how you were given 2 points and you have to come up with the equation of a line? You did that in Algebra 1, Algebra 2, you did it all the time. Now this is given 2 points. You have to come up with a parametric equation. It's a little different. It's a little tougher. But this is the formula for it. What you do is this. This is going to be x1, which is going to be the x value of your initial point, plus, and what you do is you basically just kind of take the x slope of it. x2 minus x1 times t. Yeah, we did this in ham, but RAM people did not do this. Okay, and then the y is exactly the same, but just with y's. So you take the initial y value for the initial point plus y2 minus y1 times t. That'll give you a parameterization for it. And then you have to decide where your t is going to be at, like your window for t. Okay? If it's a line, that means t goes forever in each direction, or the line goes forever in each direction, which means t has no restriction. So t would be between negative infinity and positive infinity, or just infinity. All right? If you were saying that this was a segment, a line segment, then t is always going to be greater than or equal to 0, but less than or equal to 1. 0 to 1, just like our first one was, 0 to 1. And then if it's array, then t will be greater than or equal to 0, because array has an initial point but no end point. It's like an arrow. Okay, so you have to decide. This never changes. This will be the same every single time that you're doing these, but you will have to choose between one of those three. And I mark off for that. I usually make this a 3-point problem. So 1 point for the x, 1 point for the y, and then 1 point that you told me which t it was. So let's do one. Are you excited? Yeah. Number 2. Did you say no? Sure. Sure, I'm excited. No, that doesn't make sense. All right, it says find a parameterization. I can't even say that. I'm just going to abbreviate. Parameterization. I'll say param. For the line segment with endpoints -2, 1, and 3, 5. Now, if they don't specify which one is initial, which one is terminal, just go ahead and assume that the first one is initial and the second one is the terminal point. Okay? You can assume here. It's okay. All right, find a parameterization for the line segment with those endpoints. All right? So here we go. Parameterization, I need an x, I need a y, and I need my t. Well, this is a line segment, so I know that t is going to be between 0 and 1, or n equal to them. All right, so here we go. Let's start with x. X is going to be, it's going to be x1, which is -2. Okay, this is x1, y1, and this is x2, y2. The initial point is x1, y1. Terminal point is x2, y2. And then I'm going to find like the x slope, the change in the horizontal. So that would be 3 minus -2 is 5t. It's like slope. Okay? Over here, the y would be, start with y1, which is 1, and then do the slope of y, of the y part. 5 minus 1, which is 4t. And that would be your answer. All of that. All right, let's do one more. Number 3. Okay, same thing. We're going to find a parameterization for the line that goes through the points -1, -5, and 3, 8. Okay, now these are not really initial or terminal points because this is a line that's not going to have an initial or terminal point, but you can treat it that way still. Okay, I and T, initial, terminal. We're going to find a parameterization for the line. So this is going to be x, y, and then my T will be -infinity to infinity because it's a line that goes forever in each direction.
So in the test, are you not going to say like line?
I will. I have to.
So why do we have to answer if it's like a line or anything like that?
Well, you're making the parameterization for the line. The last one was for the line segment. So if you didn't put that T part in there, you'd be wrong.
Okay.
Especially for the last one. Because if you just said this is x and y without putting 0 to 1, then I could think that that's a line. I could think, oh, maybe it's a ray. But this one, you need the T in there. All right, so, and some people like to do it this way. They like to take x1, y1, and go -1, -5. They kind of do both lines at the same time. You can do that. And then 3 minus -1 would be 4t.
Wouldn't it be -1 and 3? Oh wait, never mind. Huh?
No, yeah. And then 8 minus -5 is what, 13? 13t. There it is. Yay. It's nice, huh? If you have that formula and you kind of memorize it, it's not a hard formula to memorize. I think you'll be all right. And I thought I was going to teach parabolas, but I guess I told myself not to do this. I scratched it out on the back. So